back with another problem, and today's problem is a Padovan sequence problem, and it's an interesting problem which is just based on the number sequence, and there's nothing difficult over here in this problem statement. What you can see clearly that Padovan sequence is a sequence which is given by the formula P of n equals to P of n minus 2 and plus P of n minus 3. Okay, so this is the sequence they have given. They have also said they have also given a base case where P of 0 equals to P of 1 equals to P of 1. Okay, so you can see 1 1 1. Okay, so let's take some input and output cases. So for the input, say for the input n equals to 3, they have given the output as 2. Okay, so how we are computing this? So first, what we basically can derive from this, that P of 1 is obviously nothing but if you can write it like this as P of 1 equals to 1, because over here you have checked that P of 1 equals to 1. Okay, this is given, and also we know what else is there. So P of 0, right? So P of 0 is equals to 1. Okay, so what I can say is P of 3 equals to P of 1 plus P of 0, right? So this is given in the question. You can check the question pattern and the question sample. So you can find it like this, that's 1 plus 1 equals 2. Okay, so this is what we have to find, output. I can write it over here as output. So, and also the case is like this, that the answers can be very large, so very large. So for that we have to return the answer, return the answer modulo 10 to the power of 9 plus 7. Okay, so we have to return the answer with a modulo time constant. Okay, so how we are going to basically do this problem? So first say we have a class solution. Okay, and this class solution will have, say, a function which has an integer return type, right? So we can write int Padovan, and we can pass our number, so say int num. Okay, so this is what our function looks like, right? So we have to store the mod value somewhere in our function, right? So we can store the mod value as final int mod equals to, we have to put 10 to the power of 9 plus 7. So 1 2 3 4 5 6 7 8 7. Okay, so you can see 1 2 3 4 5 6 7, there are 8 zeros and 7. Okay, so we have defined the modulus function. Now we have to check the base cases where the n values can be either 0 or the n can be 1 or either n can be 2. In all those cases we have to return 1. Why we are returning 1? Because if you see our question, what you can see, it is saying that for 0, for 1 and for 2 as well, it will return 1. Okay, so I will write it over here. If my n equals to say for example 0, or my n equals to 1, or my n equals to 2, what I can return is I can return 1, right? What next I can do? So next I can see is I will store the values of the initial values. So for initial values I can write it like P0 equals to 1, and I will just omit this part, and I will put it over here. P0 equals to 1, P of 1 equals to 1, and P of 2 equals to 1. Okay, this is what I have initialized my variables like. Okay, so my P of n, where I will store the result, say int P of n equals to 0. Okay, here I will store the result. Okay, store the result value or the nth Padovan sequence value. So for that basically what I'm doing is I will traverse a loop. The loop will start from I equals to 0, and the loop will run till I becomes n. Okay, the loop will start from 0 to n and I plus plus. So what in this loop I'm going to basically do? I'm going to basically first write the formula. So what is the Padovan sequence formula is P of n equals to P of 0 plus P of 1. Okay, this is what we have to do, and we have to return by mod. So what is this mod? Mod has been already stored over here somewhere. Mod is already stored over here. Since the answers can be really large, we can use this mod for storing the compute value. Okay, so we have taken P of is mod. So next what we are going to do is we are going to swap this value. Okay, so this is our P of n already. So what I'm going to write is P of 1 equals to, say I will write like this, P of 0 equals to P of 1. Okay, P of 1 equals to I will write P of 2. P of 2 equals to P of n. I'll close the loop. Okay, and I will return my answer P of. Okay. So this was all about today's problem statement. So I hope you guys can execute this problem statement. I will write it over here as algorithm or pseudocode, where which you can write for any language, and it will be helpful for you. Okay. So let's compute this particular problem. So over here I can see there is a class Padovan sequence. So first I'm going to declare a static final int mod equals to 1 1. After that 1 2 3 4 5 6 7 8 7. Okay. After that I'm going to check my value n equals to n can be equals to 0, or n equals to 1, or n equals to 2. Then what I will return a default value of 1. Okay. So this was my if part. So once my if part is done, what I can do is I can store some values, like so p of 0 and p of 0 equals to 0, p of 1 equals to 0, p of 2 equals to 0, and p of n equals to 0. So I've still taken all these values. Okay. So next what I'm going to do is, as I told you, I'm going to traverse a loop. So int I equals to from 0 to I less than n, I plus plus. I'm going to traverse this loop, and I'm going to compute the value of p of n. So p of n equals to p of 0 plus p of 1 modulus of mod value. So if you see this week's GeekForGeeks is basically starting from scratch. It is basically giving you questions on numbers. It is basically giving you questions from mathematical computation. So most probably my assumption will be next sequence will be on strings, because after 100 days or say 1 month or 2 months, usually they started from the scratch. So once the p of n is done, what I can write is p of 0. We will use the swap functions. P of 0 equals to p of 1, p of 1 equals to p of 2, p of 2 equals to p of n, and like that. Okay. And finally what we can return is return p of n. Okay. So let's compile our code over here. So illegal start of express static final int mod. So maybe I can take this outside and store it over here, and then try to return. Cannot find symbol p of 0. Cannot find symbol p of 0 plus p of n equals to p of 0. Why you cannot find symbol p of 0? P of 0 I've already done. What can be the problem? So p of 0 has to be p of 1. The initial value of p of 1 has to be 1. P of 1 has to be 1. And p of I has to be starting from 3. So let's check. I equals to 0, n equals to 1. I return 1, 1, 1, 1, and 0. And then let's compile. So hopefully this should work out. So it's telling it has an output difference of 2, 0, 0, 2. So what can be the output difference? We have 0, 0, 1 and 2 as 1, and we are starting from 3, we are going till plus. So you can ask the AI if it can help. Less than equals to. Yeah, so let's try to submit. So we have successfully solved today's problem statement, and I hope you could understand today's problem statement, and we are looking forward to our next video. Thank you.